Okay, let's do this. So on the schedule, I have more database examples. I didn't update the schedule, but we're going to talk about the project today, specifically project reports. As with the last, any demo lecture, I'm just going to demo stuff today. As with any demo lecture, please ask questions. I'm not getting many questions, so I can only assume everybody's fully up to speed on everything. I think that's a dangerous assumption, so if you do have questions, shout them out, put them in the lecture channel or Discord, however you want to, bring it to my attention. All right, so let's start talking about the project. And like I just said, I'm going to focus on the reports in this lecture. So for your project, you have to build these, an app with these features, and I have more explanation in the project requirements document. To build those features, to build your app, you can use any libraries you want. I have a few small things that are banned. I think I expressly banned a third-party database. I shouldn't say I think, because I know I banned a third-party database like Firebase. None of that. You have to locally host your own database. But within reason, I don't even know if it's within reason, but with only a few exceptions, you can use whatever you want for the project. But if you use anything that's not allowed on your homework assignments, you have to write an open source report. So the open source report, this is my way of saying you can use what you want, but you have to know how it works. You have to actually know what libraries you're pulling in, what those libraries do, and how they do it. And specifically, you need to dig into the source code of those libraries and get to the point in that code, find the code that actually does the thing that you want it to do. So the first thing you'll probably do is pull in a framework, which is going to handle TCP connections, HTTP parsing the headers, parsing the requests and getting the path and the request type, all the headers in a data structure for you, and handling all those things that we did in homeworks 1 and 2 for you. So I want to see in the open source report, how exactly does that library accomplish that? And I want to know that you dug through the code, which is what we'll do most of today, that you dug through the code and actually found where the code is, where that library does the thing that you want it to do. We don't use magic in this class. You can't just pull in a library and say, I don't know, it just does the things. And I didn't have to do it, so I'm happy about that. No, you pull in a library, you actually have to dig through it and see how it works. So that's what the open source reports entail. We have more structure this semester than last semester's. Not that the comparisons are relevant to all of you, but before I pretty much left it at that and said, just tell me how the thing works with a little bit of extra explanation. Now we have a template just to standardize things a bit. The reports that I got were all over the place in terms of structure, detail, level of detail, and things like that. So we're trying to standardize that a bit more at this point in time, this semester, and giving you this template. So you must use the template to tell me about your library. So for each library that you pull in, and potentially multiple for a single library, if you have one library that's doing a lot of different things for you, potentially 2 reports, depending on how you want to organize it. Fill out this template, give me a URL to the repository, the license type, it should be some sort of open source license, but whatever the license type, if it's MIT or GNU, whatever the license is. Tell me a little bit about the license, what that means, team members who worked with it, and then for each method that you're using, or for each piece of functionality, it's not always going to break down exactly the way exactly in a nice way. But for each piece of functionality that you're using that library for, tell us what that is. Tell us why you pulled in this library. For some reason, I had trouble getting this out of students last semester and in the previous semester. It's tell me why you pulled in this library. If you did import some library, you went to your package management and installed, downloaded this library, Tell me why. Why did you do that? That's the purpose of that library. So why did you pull it in? Tell me. Why did you pull that in? It's not a complicated question. I'm not like, it's not a challenge or anything like, why did you do that? You shouldn't be doing that. It's just like, okay, you pulled in that library. Why did you pull it in? And this is something that's useful to think about even beyond this class when you're not forced to do it. Like whenever you pull in a library, like, why did you pull in that library? That's a question you should be asking and answering whenever you use any third-party software for a project. Like, why are you using that? Should almost always be a good answer, or there should always be a good answer, but just think about what that answer is. Why did you pull in that library? Is it because the tutorial you followed pulled it in? That's not a good answer. What exactly is that library doing for you? Why did you pull it in? We see this problem in 442 a lot. Students just pull in mountains and mountains of libraries just for no reason at all. And then they get later on in their project, and their project's so complex and they have no idea how it works. Then they have some really strange bug and they can't debug it because they have no idea what they're doing. That happens a lot. I want to avoid that in this class. That's why we have open source reports. I toned down this mic a little bit. So tell me first, why did you pull it in? And then, how does the magic happen? This is where you're going to spend most of your time. I would say this is where you're going to spend the most of your time for your entire project. Between writing code and the rest of this template, this is where you're going to spend the bulk of the time for the entire project. For the sake of your team, do not just assign one team member the reports. They will hate you, and they'll probably not get, you probably won't get a good grade on it either, because they're probably going to be so frustrated that they'll give up halfway through, and you'll get some zeros on your project. By the way, if you pull in a library to accomplish something for you on the project, and the open source report is not adequate, it's going to be a 0 for that feature, whatever feature you did, because you effectively didn't do that feature. So the magic is going through the code and finding how that library does what it does. And for this, we want you to follow the entire chain of method calls, or the chain of dependencies, or the chain of imports. However it works for the libraries, it's different for a lot of different libraries. We'll see some examples of things get strange fast, and we'll see examples of that today. But follow from your code to the code that actually does the thing that you pulled in that library to do. Follow that entire chain of how you get from your code to the code that does the stuff. And for this, I want links to the actual code. You should be pulling in open source libraries. That means the source is out there. You can give me a URL to that source. And then if you have a library where it's doing multiple things, you can either break it into multiple reports or use each section, use the multiple sections for the report. So as many of these as needed. If you pull in a library to do one thing, you have one method call for it, just fill out one of these sections. All right, who's ready? Let's get rid of this. So let's do this. Let's trace through some code and try to dispel some magic. This is, and I don't say it lightly that this is going to take you probably the most time of your project, because even I get lost in these libraries. We'll see it today. Hopefully I'll get to some endpoints and actually find the code that does the thing. But the chains get long and complex. It's navigating this code takes a while. So I'm going to start with an easy one, just because I want to start off with a win. But we want to go through the code and find where the code does the thing. So I have this one import here that I'm going to focus on first, body parser. This is going to parse the body of a request. Pretty straightforward. It's going to, after all the headers and all the HTTP stuff is parsed, it's going to look at just the body of the request and parse that based on a few different formats. So if I'm pulling in body parser, my reason for pulling this in is to parse the body, but to parse the body of the request in a handful of specific formats. For example, body parser will not parse multi-part forms. That would be a separate library. If you want to parse multi-part forms for your file uploads, which you'll want to do, you'll pull in another library for that. Body parser doesn't do that. So the first thing, why did you import body parser? Well, because the Express tutorial just had it imported. That's probably why you have it imported to begin with. But what actually does that library do? That's what I want you to discover. And do you even need it? Do you need body parser? I don't know. Some of those questions will be more meaningful. I don't know. I don't have a good feel of how far each team is with their project. But if you're using Express, you probably have this line in your code, import body parser. And then we add the body parser as middleware somewhere in here. So I'm using it to parse JSON. So I'm adding that body parser middleware to parse bodies that are formatted using JSON. Which, as we'll see, does very little. Like, I can just take the body and do JSON.parse. I don't need this library at all. Just a heads up. And some teams, that is kind of part of the thought process I want you to go for. And some teams say, you know what? I don't need any of these libraries. I'm just going to treat the project as a homework and avoid all these reports. That option is on the table for you if you want to take that option. So if you say, man, these reports really suck, I don't want to do them. So when you import anything in a Node project, you're going to get a directory Node modules, which has all the code, which is super convenient. I highly recommend when you're doing this, you pull up an IDE, download all the source of the libraries that you're using, and then navigate the source through your IDE. And then once you find all the files, each step of the path, go find the GitHub repositories for each one, and then give me the links for the GitHub repositories. So I didn't run npm install yet, so I want to start right from scratch. Npm install. That's going to grab all of my dependencies. So I have these libraries that are going to be downloaded, but if you ever looked at a Node modules directory, which we're about to do, you'll find that we get a lot more than that. We get all of these libraries. It's a lot. So and this is partly the NPM ecosystem. Each library is going to have its own dependencies. So like, for example, I want to go to body parser here. And go to body parser. Body parser has its own list of dependencies. Body parser depends on all of these libraries to get its job done. Some of those libraries are going to have their own dependencies. Some of those will have their own dependencies. So every time you import one library, you actually get a huge amount of bloat in at least in your directory structure. You have a lot of code that you're importing to get even just the simplest thing. Even just one library is going to have dependencies on dependencies on dependencies that all need to be downloaded and added to your project. That's why npm install always takes so long to run, because it's downloading all your library, all your dependencies, all their dependencies, all their dependencies. It's a lot of stuff that needs to get downloaded. So let's look at this. Let's start looking at the code. So I imported body parser. Let's see what I get. Let's get rid of this. Let's get rid of this. Let's see what I actually get in this code. So when I import this, if you weren't aware of this, hopefully we're at least at some level, but I'm going to make it really real right now. When you import a library, when you download a dependency, you're literally just downloading the code for a project that somebody else wrote and then using that in your project. So I downloaded this dependency, and it's just JavaScript code. It's Node code. And I get this code that I can call. I can call the methods on this code and use this in my project. So when you use dependencies, and even when you use standard library methods and classes and stuff, you're just using code that somebody else wrote, which is one of the glorious things about this field is there's so much free code out there that other people wrote and just shared with us for free, millions and millions of lines of code that you can use without having to do anything. And then I always find it hilarious when like a freshman or a high school student, nothing wrong with them, but they'll write a web app and they'll be like, wow, I did this really cool thing, and they wrote like 50 lines of code maybe, And it's really cool. I don't want to put, I don't want to make that about, I encourage that. I don't want to discourage that at all. But when I think about like how much code, like the phrase "standing on the shoulders of giants" comes to mind. Like how much code they use that other people wrote to be able to get that to work. That they just say import this, import this, import this, and they slap like 50 lines of whatever on top of it, and like, hey, look what I built. I mean, I think it's awesome that the barrier to entry is so low that you can do that. But just realizing, like, when I first started out, I'll speak from personal experience. I didn't realize how much code from other people I was using. Like, there's tons and tons and tons of code that other people wrote and just said, have this for free. And then in like a class like 442, it cracks me up on a different level. I know I'm getting sidetracked here, but it cracks me up on a different level because students will write, at that point, maybe 500 lines of code for their app, and maybe a few thousand by the end of the semester. And there's always a few teams who are like, I need this repo to be private because I want to protect my IP. Like, you got maybe a few thousand lines of code that's built upon millions of lines of code that people gave you for free. And now all of a sudden you're like, I need to protect what's mine. Like, give it back, man. Pay it forward. Nobody's going to want their app anyway, to be honest. But they always want to make it private repos and protect their stuff, which you probably felt the same way. I understand the feeling. But when you realize how much free code you used to make your app work, like, that's extremely selfish, in my opinion. It's wild. There are good reasons to make private repos, don't get me wrong, but protecting your IP when you use so much other people's IP that they gave you for free with open source licenses feels a little strange. All right, so let's look at this. Hey, we even got the copyright, Douglas Christopher Wilson. Thank you, sir. Given it with the MIT license. The MIT license says, here, have it. Do whatever. You can use this and profit off it. Doesn't matter. Anything you want to do with it. MIT license says, I wrote this code. Here, everybody do whatever the hell you want with it. So thank you, Douglas. So let's look at the body parser. Let's finally get into this thing. So with the body parser, I want to, and this is where things are going to slow down because it takes a while to go through this stuff. These parsers, if I get to this point, once the task is to actually parse, where's my parse method? Body parser. Once the task is to actually parse something, which is going to be middleware. And that's JSON only. Oh, it's going through each one. It's going to have to pull up a separate parser. This is something we're going to see a lot. There are multiple parsers, 4 different parsers that this library can use. And when the task is to actually parse something, like I have a body I need to parse, it's going to decide which parser is necessary. Now we can either parse JSON, raw, which I assume doesn't do anything. We can take a look at the code for this one. Text, which I don't know what that one would do either, probably nothing. Or URL encoded, so looking for our ampersands and equals. And this is the one I want to dig into just because there's stuff we know to look for. If it's URL encoded, we know we're looking for ampersands, we're looking for equal signs, we're looking for brackets. We know what that means. URL encoded, just a reminder if you forgot, is a format for query strings. So we can use that same format in the body of a request. If you have a form and you set the encoding type to URL encoded, that's the format that you're going to get in the body, and this body parser is going to help you parse that. In JSON, I want to look at JSON as well. We might end up looking at all these, who knows. So for the parser, we're going to pull in one of these libraries. Whenever you see a dot, a leading dot in the path for a requirement, that means that it's in Node, in JavaScript at least. That means that this package is in this library itself. So we have dot lib types, and we can see our 4 parsers. So URL encoded, actually, let's start with raw, because I assume this doesn't do anything. Parser, body already parsed. There's a, if I can vent a little bit about the Express ecosystem. So this is going to say if there's a variable named _body, if that exists, then I'm going to assume it's already parsed because that's one of the internal variables to this library. Then just return it's already parsed. Because during parsing, it's going to populate that variable. If you have code that wants to use that variable name in the request object, it's going to break your parsing. It's going to break your body parsing. So that drives me nuts. Effectively, the global namespace in Express is completely polluted with all kinds of stuff like this. It's frustrating, but it is what it is. But if that doesn't exist, then our task is to parse. Skip empty body. Read the content type for what it's worth. Oh, just to log it. Should parse. And just read. Yeah, it looks like it's just doing almost nothing. Maybe not nothing at all. It's checking the encoding types and things like that, making sure it exists, making sure everything's the way it should be, I guess. Making sure there are no errors, doing a lot of error checking, but not really doing much at all oh, I ended up in the read module. That's why. Yeah, and then raw just doesn't add anything to it. Okay. So let's go to URL encoding. Let's go to this one. The read is going to be used by all four of these. I didn't realize I switched over to that package. All right, so let's take a look at URL encoding. When we want to parse this, we should see some URL stuff, but spoiler alert, we're actually not going to. We should see all the stuff that handles URL encodings. We're actually not going to get there when we get to the parsing. There's a lot of duplicate code in here. In this library. When it actually gets to the parsing, we're going to pull in this extra library and say, pull in the QS library. This does not have a leading dot, so that means we're deferring to another dependency, that we have a dependency in this dependency itself. So we're going to pull in that parser, and that's the parser that's actually going to do the work for us. So if we look through this and figure out where that's being parsed, right here, we're going to parse the body just by deferring to this other library. So most of what this library actually does is just the error checking, the stuff that we saw when we were looking at raw. Error checking, making sure encoding types are correct, making sure everything's formatted properly. And if it isn't, then return a 400 level error. Say, hey, something went wrong with this. You don't have things set up the way we want it to. So once we finally call parse, and this is very common too, we're going to call parse, which is one of many other things. Parse is an interface, and then the actual implementation of parse depends on the specific application. So in our case, parse, in this exact scenario, parse is going to be, oh, where did it come from? Parse is either going to be this query string or the QS library that we saw before. Your simple parser, oh, here it is. So, and we can do that by name. So at some level in this library, we can specify, do we want to use the QS library or the query string library? So we can use either one of these two libraries. I don't know why you'd use one or the other, but I'm sure there's some specific reason. So let's go to one of these libraries and figure out how it's actually parsing. So we have two methods in this library, or two functions, I guess, at this point. Stringify and parse. Makes sense. Those are the two things we would want to do. And we're concerned about parse right now. That starts with a leading dot. We know it's in this library. We're going to go to parse. And here we actually get to see things. We have a delimiter of ampersand. That's something that we want to split on when we're parsing query strings. So I'm going to look for that delimiter actually. We're taking the value we want to parse, the query string or URL encoded whatever, body in this case, that we want to parse. And the first thing we're going to do is split it on that delimiter. We're going to take this URL encoded string, parse it on ampersands, and get each of the key value pairs. And then we're going to start looking for brackets, equal signs, looking for each occurrence of those, and actually do all of the parsing. And that's where the magic happens. So we finally arrived at the code that we're interested in. So the path to get there where's my code? The path to get there was adding this body parser, and I actually added the JSON parser. So I almost snuck that one by without explaining it. So the reason I like to do this in the IDE, your favorite tool, my favorite tool, your best friend when you're doing this kind of stuff, is the control click. If you control click on something, it'll take you to its definition. So I'm calling bodyparser.json and adding that as middleware to my app. I'm going to control click on JSON. Actually, well, let's do URL encoded because that's the one we're talking about right now. I'm going to control click or command click because I'm on a Mac on it, and it's going to take me to its definition. So it took me right to that library, the body parser library in the node modules directory, and it took me right to where I want to go. Defining this URL encoding, which doesn't tell me a whole lot, but I do see one more method call. Create parser get parse getter, load parser by name. The name was URL encoded, so it tells me to go to this library. In each one of these steps, this would be part of your magic section. So I'm going to go to this library, URL encoded. I'm going to find where this requires another library. I'm going to go to this library. I'm going to go to its parse. And I'm going to finally find the parse method, parse values, a method that actually parses URL encoded strings. So that's the path that you would need to show in that magic section. And for each one of those steps, I want to see the actual GitHub repository. One simple way to do this that's pretty effective, sometimes doesn't work, but I'm just going to copy some random code. I'm going to go to my friend Google, or my friend DuckDuckGo. No, Google, I didn't set it. And look for something on GitHub. And try putting quotes around this. It's just a gist. I don't want that. It's to embed it. Don't want that. So I didn't get to cheese that one. So I'm going to go GitHub. What were we doing? QS? QS lib parse. No match. I believe I'm in the right library. Maybe not. I might not have found the right library, but I don't want to spend too much time doing that. I kind of have to, don't I? So over here. It'll take me to the issues. Yeah, it was the right library. I might have an older version where things are just organized a little differently. Yeah, I just have an older version, so there's been an update. We got formats added to it, which has different different standards. Makes sense. New standards, got to add more stuff. We lost our, no, delimiter's right here. Split on the delimiter. So a little bit different just because I have an older version of the library, but the same idea. It's doing the same thing. Now once you find, so once you find this, like this is the method that does the function that does the stuff. You want to do this for the whole chain, but once you find specific code, please do the link for that actual code. So go to the line number and copy that link, and then put that link in your report. Don't just give me a link to a 1,000-line file and say it's somewhere in there. That doesn't tell me that you actually looked through the code and understood what's going on. And two, it's just a pain in the ass to do. Some of these methods, like this one isn't too bad, just a couple hundred lines. But some of these functions, especially when you, some of these files, especially when you get into the standard libraries, thousands of lines of code. I think that's gross, but you know, that's how things are. That's how some things are. Man, that one took like most of the time. All right, so that's an easy one. I can do that, you know, in the confines of, you know, part of a lecture. It's not too hard. It would take some more time just to write up the report and everything, but not too hard of one. Once you get into Express, you're in for a trip. I'm not going to go the whole way through this one. I'll leave that for you. So the first thing, if we just control-click, we get into TypeScript. If you get into TypeScript and it's just defining types and there's no content, you're going to have to look elsewhere for that. So I'm in a types directory. This is just defining types to map TypeScript to JavaScript. What I need to do is manually go up to Express. It requires Express in the lib directory. Which requires all kinds of things, and exports create application. So this is the method you're calling when you actually say Express, give me a new app. It's calling this create application, which sets up the middleware, adds a couple extra methods to it, but doesn't actually do a whole lot. Creates the initial request and response objects, but doesn't do a whole lot. So we kind of hit a dead end. We can look at init, but which init? App.init, what's app? Doesn't really have anything. It gets tough to follow these things real quick. App.handle, we can try going in here. And we find a type. Connect, we can try to go to connect. Is that not a library? No. So we're quickly going to run into some issues with that one. So Express, here's where it helps. Sometimes the links, the links can get fuzzy when you're following the whole chain. It's okay if they get kind of fuzzy as long as it's clear that you followed a path through there. So what we can do is look through the imports and figure out what this library is using to actually do stuff, because Express actually doesn't do much of anything. It adds this structure for middleware, but it actually doesn't do much at all. What it does do, if we can find it quick enough, what it does do is defers to HTTP for most of the work. Maybe it's in request, we can find it. And we can see our net for those of you who use JavaScript for your projects. But we're quickly going to find that it defers to HTTP for most of its work, which is a library in Node itself. When we get to HTTP, I believe it's not in this list, right? When we get to HTTP, we're actually in Node itself. So we're going to have to go through the Node source code, which you can try to download the sources in your IDE or go to GitHub itself. So GitHub, sometimes you're going to have to go into GitHub and navigate the code directly in the repo itself. So I'm in Node, I'm in HTTP, and I can start looking through this code to figure out how this code gets the job done. And it doesn't do much either. You're going to hit a lot of dead ends, I'm warning you right now. You hit a lot of dead ends on these paths. You get to libraries that don't look like they do anything. And to get to the actual work that's being done, it's going to take some digging. Like, how do these libraries actually get the work done? Because there's layers and layers of abstraction, and on top of the actual code that does the work is buried in some of these libraries. So just a heads up, that's what takes so long, is finding where the actual code is that does the stuff. Here we have like HTTP common. If we go up here, we can go to HTTP common and start seeing, at least seeing things that look like what we want them to look like. We're starting to see, it's not the one I want to go to, incoming. We're going to start to see some HTTP stuff that we recognize, like an upgrade header, content type. Ooh, that's good. We're getting close. But then, for example, getting to the point where these headers are parsed. Like, the headers are already parsed at this point because we're reading the headers here. So getting to the point where the headers are actually being parsed. Where are we looking for /r/n? Splitting on that, looking for colons, and actually getting the information for the headers. Where is that happening? Because it's already done at this point. So it becomes a journey. I didn't expect that first example to take quite so long, but I do want to show at least some Python. So let me jump to a Python example. It's the same idea, just a little bit different structure. We don't have quite as crazy of a dependency tree as NPM ecosystem. So that can make things a little easier, but it's still not objectively easy. So again, I didn't install all my libraries, or did I? No, I did here. You'll see them all as external libraries. So let me look at my app. And what one do we want to go for? I did Socket Io to prepare for lecture. I don't know if I want to do that one. I might as well, though. But we'll go to Socket Io, and I want to see how are these sockets being handled. For sockets, if you pull in a socket library, a WebSocket library, I'm looking for two things when I'm doing a report, and the TAs look for two different things when they're looking for a report. That globally unique ID, somewhere at the end of your chain, you better have a file that has that ID in it, because that has to happen for every single WebSocket connection. That GUID, that global unique ID, has to be used to generate the accept header. So I'm looking for that, and I'm going to look for where frames are being parsed and where frames are being assembled to be sent. So I need to see those two things. If you say, I use the library for sockets, for WebSockets, I need to see those things. They better be in your report. So, and Socket Io does not make this easy, just another heads up. Socket Io is a nice library. It adds a lot of niceties on top of WebSockets, like automatic reconnects, message types, and a fallback to long polling, actually. So it has some niceties. You'll probably want to use Socket Io, or probably not if you want to avoid the report. But Socket Io is going to handle that stuff for us, a lot of the WebSocket stuff. So when we create a Socket Io server, again, it's going to be a familiar story. Not a whole lot happening here. Not a whole lot happening. This object is going to be used by other code later on. So the chain of where the stuff happens gets a little convoluted. We're just adding this to, we're going to call it init app. We're just adding this to our server. And this is actually Flask Socket Io. So this is Flask's version of Socket Io to be able to be used with Flask web servers. So quickly in here, I didn't spot it right away. We're going to find, let me just check the imports. Oh, because it was collapsed. No. Port Socket Io manage. I think Socket Io manage is the one we want. Socket Io manage. More imports far down the file. Import Socket Io. So we're going to quickly find that it actually uses the Socket Io library. So there's a Socket Io library in Python that does, in any, most languages, that does all the Socket Io stuff. And then Socket Io Flask is just a middle, is middleware the right term there? But it's an adapter. It's an adapter library to be able to use Socket Io with Flask. So it communicates between Flask and Socket Io, but it doesn't actually do much. And again, that should be a familiar theme now. I said that a bit during the lecture. The library doesn't do much. It's just an adapter to be able to use this library with Flask. So this library is actually doing the socket stuff. I get to, where's the top level? Go to the server. And if we go through this code, I'll warn you right now, anywhere in this library, you're not going to find that globally unique ID. So this actually defers to managers to be able to do the stuff that it needs to do. And then there's going to be a manager which actually handles the WebSocket stuff. So the WebSocket stuff isn't even handled by the Socket Io library. So if we get into, I don't know if I can remember this chain immediately. But if we go into one of the managers, I'm just going to cheat a little bit. Goodness, where's my code? I'm going to add Tornado on here. So one of the managers is for Tornado. So I'm in Socket Io. There's a Tornado manager, which is going to check if the Tornado library is imported, if it exists in this project, and if it can import it. If it can import it, then it's going to use that tornado.websocket. And it's going to do this for multiple different libraries. It's going to check if the library can be imported, and if it can, it's going to use that one. And if it can't, it's going to go down to its default options. So Tornado, I'm in here. I'm in the Tornado library now. I'm in the WebSocket.py file of the Tornado library. I have lots of comments. If there's a header of upgrade, ooh, we're looking at some good stuff now. Connection, upgrade, connection, checking the origin, making sure we don't have cross-origin stuff. Sending some 400s if things aren't looking right. Oh, and we hit the end of that thing. Accept connection. Oh, damn it. Why? Got abstract methods. We're in an abstract class there. Just give me what I want. We got 4 minutes. We can get there. Ooh, look at this. Bytes of a frame with masks. Ooh, yeah. So, in reserve bits, now we're looking into how to, I was trying to find the connection, the handshake first, but we stumbled upon the code that's actually going to parse these frames. So, we have our masks, stuff that you saw in, stuff that you're using on your homework, masks to get the correct values. Where are these used? Oh, I thought it was going to be right there. Opcode. Oh, taking the header. Okay, yeah, I see. And then masking it, getting the opcode, and doing doing our thing. Oh, that was just setting the variables, I see. And then when a frame is received, we're going to actually use those variables, do our parsing, get our payload length, depending on, if is it less than 126? Is it 126? Is it 127? And getting the actual payload from that, all that stuff that you're doing on your homework. Here it is. We found it. So that should be the endpoint of your chain. That's where I finally found the code. And for this one specifically, if you just say, I'm going to assume it's using Tornado, that's fine, because that's what I did in lecture anyway. Let's find that global unique ID. In the interest of time, 2 minutes left. Hey, there it is. A magic value. Nice comment there. This is where we're going to compute the accept value. We take that key that we read from the headers. We're going to pull in our hashing algorithm. We're going to add the key, append this, hash it, base64 encode it, and return that. So we found where the handshake is, and then wherever this is called from. I can right-click and find usages. Let me find the spot where this is called from. So we're going to not do much. Read that header, and then send it the header. We can check where this was called from, and kind of work our way backwards too. Find usages. That's where we're setting the handler for that header. Reading our upgrade and connection. Ooh, all good stuff. Sending the 101. So now we're getting into the code that we actually wanted to find. Take some steps. We go from Socket Io Flask, I forget which order it is, to Socket Io, to, you might actually end up in Engine Io, is another library used by Socket Io. And then we looked at the handlers, found the list of handlers, went into one of those handlers because we don't know which one is actually going to be used when we run our code. It works through the interface, and the actual implementation is abstracted out. So we picked one of those handlers, found that library, and then actually found our code that does the stuff. So these chains get long. This takes a lot of time. Not joking when I say it's time consuming. But this is what I expect from the reports. So hopefully that clears up a whole bunch of questions about those. And we're out of time. No questions in chat. So have a great weekend, and I'll see everyone Monday.